and start recording. So we had, kind of started with the generic of using like the right triangle, trigonometry, but again, as you saw with most of the examples, we were using the inverse trig function, right, to be able to find our angle measurement and then kind of build up on that. Then we got into how we could use sinusoidal functions like, your sine and cosine to basically help us come up with again, models and how to solve them. So the last example we had talked about was this one right here with the spring, being stretched beyond its natural length and how that would occur. So the last example that I kind of wanted to talk about was this one over here. So you can see we are talking about, let me get my little pointer here. So we're basically saying, what if, we had to model a behavior which was more complicated than just our basic sinusoidal function. So that is kind of where this example is coming in. And I'm going to try and see if I can get that image on the same screen so you can kind of follow the description with the image here. So you can see they're talking about a rigid rod with a length of 10 centimeters. So that's actually going to be this rod here that we're talking about. They're saying this rigid rod is attached to a circle of radius 4 centimeters at point A. So you can see point A is going to be a point on the circumference of the circle. And of course, then they're telling us the radius of the circle is 4 centimeters. And then we have a point B, which is able to freely move along a horizontal axis, driving a piston. And again, they're saying if you wanted to see the animation for this, they're kind of giving us a link over here. Oh, interesting. I guess because they didn't give us the full link, it's not opening. Well, that's a bad design on their part. Okay. Well, basically, they're saying if the wheel rotates counterclockwise at 5 revolutions per second, find the location of point B as a function of time. When will the point B be? So the point B be 12 centimeters from the center of the circle. Oh, you're not able to hear me? Okay, hold on. Sorry. All right. So Zadok is saying that he is unable to hear me. I'm hoping the rest of you can hear me. Yeah? Okay. All right. Thank you for letting me know. So, okay, maybe he can log out and come back in and that'll help. All right, guys. So basically the idea is we know this point B is moving along a horizontal axis, right? They're basically saying it's driving a piston. So the idea is, the wheel here is moving counterclockwise, right? At 5 revolutions per second. And they basically want to know when will point B be at a distance of 12 centimeters from the center of the circle. So we're trying to figure out how to get to that, right? So it will be, as they told us this will be a little bit more of a complicated situation. So let's see how we can go about figuring out that total distance. Basically, from the center of the circle to point B, we want to know when this distance here will be 12 centimeters long. So they are saying we need to find by start by finding the coordinates of point A first. So they're telling us, since we know this is a point on the circle that has a radius of 4, we can basically use the formulas that x and y are equal to r times cosine of theta for the x value and r times sine of theta for the y value, right? And we know the r value is 4 because they're giving us the radius of the circle. So you can see they kind of start out with, okay, this gives us our x value. This gives us our y value. So we kind of have a starting point for, the ordered pair for the point A on the circle. Then they are telling us we have an angular velocity of 5 revolutions per second, which is also given to us in the problem, which basically equivalently comes out to be 10 pi radians per second. Does anybody know where we are getting that value of 10 pi radians per second from? We talked about this in chapter 1 or chapter 5 from your textbook. One revolution is 2 pi. Very good. Zadek, since you are back, are you able to hear me now? Yeah, wonderful. Very nice, Logan. So yeah, since we know when you move around a circle, you go that one full rotation. Obviously, in radians, we know that's a value of 2 pi. So yeah, you're basically taking 5 times 2 pi, which of course will give you the 10 pi radians over here. So yeah, very nice. So you have 10 pi radians per second, and then we're saying, okay, after t seconds, the wheel will rotate by, whatever that angle will be based on the 10 pi for the revolution, right? That total time. And then, of course, for how long has the wheel been rotating, right? So that will give us our angle measurement. So they're saying now that we have this value for theta, we can now go ahead and substitute that in our 4 times cosine of theta and 4 times sine of theta. And that will give us like the new value for the point with the t variable, right? Okay, so now they are saying that the same value we would have obtained if you looked at the period of the rotation. So we know the period of the rotation is 1/5 of a second, right? Because if 5 revolutions happens in 1 second, then we can of course say the period is 1/5 of that. So even if you use the original period divided by the new period, you can do 2 pi divided by 1/5. And, again, simple math over here. If you're taking 2 pi divided by 1/5, we can change that division to multiplication and then invert the fraction of 1/5, which will become 5/1. And you can see that also gives us that same value of 10 pi radians per second. So they're telling you 2 different ways of how we could have come up with this answer. Okay, so we have the coordinates for point A based on the value t. Now they are saying we can relate this to the point B, and you can kind of see the image over here where they are drawing a vertical line over here from point A to the horizontal axis. And you can see when we create that little right triangle between point A, point B, and, of course, this vertical line that we drew from A to the horizontal axis, we have a nice right triangle over here. So they're saying we know the height of the triangle is going to be the same value as the y coordinate from your point A, because that is the vertical distance, right, from the horizontal axis to point A. So the distance will be that same value of 4 times sine of 10 pi t, right? So we've got our, um, you know, since they're calling this B, I'm just going to call this A. So, A squared plus B squared is equal to the hypotenuse square. So that's your Pythagorean theorem. And you can see once we plug that in the Pythagorean theorem, you can go ahead and solve for B over here. So just, yeah, your basic simple math with the Pythagorean theorem. And remember, this will still be in terms of t because we don't know the time yet. But go ahead and simplify this. Basically, you can see the 10 squared becomes 100. We are trying to get b by itself, so we start by moving the 4 sine 10 pi t to the other side. Since it's squared, 4 times 4 will become 16. Sine, of course, becomes sine squared, and obviously the sine is being squared, not what's on the inside, so the 10 pi t stays as is, but you do put the square on the sine value. Okay, how did we get the graph? Okay, so basically look at this original image we had over here, Ryder. So you can see we can basically drop a vertical line from the point A to the horizontal axis. And you will see when we drop this line over here, it creates this right triangle. So you get that right triangle. Of course, this is going to be a 90-degree angle over here. We don't know what this distance is, so we're calling that distance B. We know the coordinates for point A over here is going to be 4 for the radius of the circle, for cosine on the x value, and then of course it's 4 times sine for the y value. And then once we did this calculation over here, our theta value was 10 pi t. And of course, that's going to be the same for the x and y values. So, just imagine if this was just any circle, on the x and y coordinate plane, if you have a point anywhere on that circle, we know this distance and this distance can be calculated by whatever your x and y coordinates are. So we know the vertical distance is going to be the same value as your y coordinate from that point, and the horizontal distance will be the same value as your x coordinate from, again, that point on the circle. So that's the idea we're using over here. So we know this distance from A to the horizontal axis is going to be the same as your y value here. So that's why this distance we are calculating as 4 times sine of 10 pi over t. You have your b value, which is the other side of your right triangle. So remember, with your Pythagorean theorem, you can do a square, which is this side, b square, which is this side, and then it equals your hypotenuse. And of course, we know the measurement of the hypotenuse is 10 centimeters, so you can do your hypotenuse squared. So remember, this is following the a squared plus b squared equals c squared from your Pythagorean theorem. So does that kind of help see where we got the numbers from? Yeah? Okay. Did anybody else have questions on how we use the triangle to try and come up with the formula for B? No? Okay. All right, so I am actually going to erase this and come back to where we were. So yeah, as I said, over here, you're basically squaring the 4 and you're putting the square on the sine function. We, of course, square the 10 squared to get 100. And then to get b by itself, you would, of course, use a square root on both sides. Now, again, guys, remember, normally when you bring in a square root, the square and square root, of course, cancel out, but you also get a positive and negative value. Now, since we know specifically that b is going to be this distance over here, you can basically discard the negative answer because we know since it's a distance is always either 0 or a positive number, right? So we don't need the negative root. So that's why you will see they did not bother with the negative root in this formula because we know it's a distance and distance is going to be positive. So we have now a generic value for B, and you will again see it's based on, whatever that value T will be based on, how long the wheel keeps rotating, I guess, in a way to think about it. Okay. So now they are saying, looking at the x coordinate of point A, we see that the triangle we drew is shifted to the right of the y-axis by 4 times cosine of 10 pi t. So we are basically saying, okay, if we take this offset with the length of the base of the triangle, so they are basically saying, this distance over here is given to us by the x coordinate of the point A. As I was explaining to Ryder earlier, just imagine, we're talking about, again, this distance and this distance comes from your x and y coordinates. The vertical distance comes from the y, the horizontal comes from the x. So obviously, if this distance here is x, obviously we know this distance here is also going to be x. So that's what they're talking about when they say that the triangle has been shifted to the right. We're basically saying this distance here is the same as your x coordinate. For point A specifically, we know the x coordinate has this value here. So to find the distance from the center of the circle to point B, you take that distance from the right triangle, which is of course the B value here, and then add that distance between the center of the circle to where the triangle begins. And that's the x coordinate from our point A. And when we put that together, we will know the distance from the center of the circle to point B. And remember, our question asked us, when will point B be at a distance of 12 centimeters from the center? So then we know, okay, this value has to be 12. So you can see in this equation, you replace your x of t with 12. And then we are obviously going to be solving it backwards because now we need to get the value of t by itself. So we need to isolate the t. And again, guys, honestly, at this point, we're just doing algebra. But since the t is in two separate places, we will, of course, need to find a way to bring them together. So let's see how we need to go about doing that. All right, so we've replaced our x of t with 12. You will see we start by subtracting 4 times cosine of 10 pi t, right? We bring it to the left-hand side and subtract it from 12. Now we need to get rid of the square root. So of course, to get rid of the square root, we need to bring in square, right? So your square and square root on the right-hand side will cancel out. But look, now you are going to have a square value on the left-hand side. So of course, you can use FOIL to do that math. And again, just to refresh your memory, we are doing 12 minus 4 times cosine of 10 pi t multiplied into itself. So 12 minus 4 times cosine of 10 pi t. So think of this as one single term. So you are multiplying 12 with 12, which is where the 144 comes from. Then we are multiplying 12 with negative 4 times cosine. So of course, positive times negative is negative. 12 times 4 is 96. So you get negative 96 cosine of 10 pi t. Then you are multiplying negative 4. Sorry, no, not 96. It's going to be 12 times 4 is 48 times 2, which is where the negative 96 comes from. So sorry, I skipped that. Negative 4 multiplied into positive 12 is negative 48. But since we end up doing it twice, right? We do it once here, we do it once here. You get negative 48 and negative 48, which adds up to the negative 96. And then the last part to do is multiply the last two terms. So negative times negative will become positive. 4 times 4 is 16. And of course, we're multiplying cosine with cosine of 10 pi t. So you get cosine squared. So again, it's algebra. You're using FOIL to basically expand the left-hand side of your equation. Once you get to this stage, now go ahead and combine like terms. So basically, we can start by subtracting 100 on both sides. So you can see 144 minus 100, of course, just gives us 44. We are also taking our negative 16 sine squared 10 pi t and moving it to the left-hand side so that we can get 0 on the right-hand side. So you're basically bringing all the terms on the left-hand side now. None of these are going to combine other than the 144 and 100, but you can see, and I'm actually going to go ahead and clear this out, but you should be able to see that both of these terms have a 16 in common. So you can actually factor out a common 16, bring it on the outside, and then we can go ahead and combine cosine square of 10 pi t with sine square of 10 pi t. And we should know this from the Pythagorean identity that cosine squared plus sine squared is equal to 1, right? And which is the idea of combining these two terms over here, because now we can say cosine squared of 10 pi t plus sine squared of 10 pi t. As long as both of these angle measurements are the same, you can use that Pythagorean identity, and this is going to equal 1. So basically, we are saying 16 is being multiplied by 1, and you can see that's where that 16 comes from. So it does start, kind of looking a little ugly, right? Because there's just so much happening there, but you are actually able to simplify it quite a bit and then look at what you are left with. So we've got the 44 from here. We've got the negative 96 of cosine of 10 pi t, and then the 16 times 1 just became 16. So obviously we can combine the 44 with the 16, right? You can go ahead and combine that. That adds up to 60. And you will see that they added these guys together. That gave us a 60, but then they moved that 60 to the other side. Because now what are we going to do? To solve this equation, you need to get that cosine function by itself. So move the 60 to the other side, then you divide by 96 on both sides. Get your cosine of 10 pi t by itself. You have two negative signs, so it ends up becoming positive 60 over 96. You can see they're using that u substitution here again. So figure out what u is going to be by using cosine inverse on 60 over 96. And then, of course, we'll undo that substitution, right, to figure out the value of t. So once you have 0.896, they're saying you can again use symmetry to find the second solution, because within one revolution, we know cosine has two different values. So you can go ahead and use the symmetry to find that second angle value for u. Once you have the two answers, guys, this is where we undo the substitution. So to get t by itself, of course, you are going to go ahead and divide both sides by 10 pi. So you get your t value here. Same thing, divide both sides by 10 pi. And you can get your t value over here. So basically, we are saying that there are, for two different times, where B, the point B, which is moving that piston, will be 12 centimeters from the center of the circle. So they're telling us the point B will be 12 centimeters from the center of the circle at 0.0285 seconds after the process begins and 0.1715 seconds after the process begins, and then every 1/5 of a second after each of these values. Now remember, where is this 1/5 coming from? Remember, that's the period of our rotation. And that's why they're saying, at every 1/5 of a second, as the wheel moves, that point B, which is, helping move the piston, or that rigid rod, which is moving because of the wheel, will be at a distance of 12 centimeters from the center of the wheel or the circle. And you can see what that looks like. So, like I said, a little bit involved. It's honestly not that complicated. It's just there's a lot of like simplifying and solving happening over here. And, 90% of this problem, guys, is algebra more than trig. Yes, we are using trig functions and some trig identities, but you will see most of this calculation was honestly just using algebra to simplify the problem. So this is kind of a little bit more involved and more complicated than other examples we had done, but I'm glad we had time to at least go over it and look at it. So Ryder, it does happen twice per rotation. So it will happen when you first start out at the 0.02 seconds after the wheel starts moving, and then it happens again at 0.1715 seconds. So you will actually, within one rotation, get to 12 centimeters twice. Did that make sense, or lost you? Oh, okay. All right. Okay. I'm glad. Did anybody else have question on like breaking down this example? Okay, so since we didn't really get to do a lot of examples last time, again, because I was in such a state of panic, let's do some simple examples first. So I don't know. Mm, okay, so they're asking us to solve for the unknown side, and angle number one looks pretty straightforward because we can actually just use Pythagorean theorem to find C, but then we of course need to find angles A and B. Let's do number three since it's actually not giving us the side A, so maybe that'll be just a little bit more involved. So we'll start with the right triangle example here, and then we'll build up on that a little bit. So let's do number three over here, guys. And of course, if you wanted to practice any of the others, you're welcome to do that. Um, all right, so this is, of course, our 90-degree angle. This is angle B, angle A. We're given 7, the side B, and the hypotenuse is 15. Um, so we are basically trying to find side B. We have to find angle A, and we have to find angle B. So take a couple minutes. Think about how you are going to find the missing side, how you're going to find angles A and B. And when you are ready, share your answers with me on the chat. And as always, make sure you're only sending the reply to me, not to everyone on the chat. And if you get stuck, you need help, let me know. All right, Zadok, I see your answer. Logan, I see yours. You've got the B value, angle B, angle A. Zadok, I see what you did here. So you're taking angle A. Okay, angle B. And then, okay. All right. So yeah, I mean, obviously since we're talking right triangle trigonometry here, right? Think about SOHCAHTOA that we had kind of talked about in chapter 5, right? Or chapter 1, however you want to think about that. Nathaniel, I see yours. So Nathaniel, that number looks fairly big for side B, so I think you should be able to simplify that radical. Um, So as you are working through this again, remember SOHCAHTOA. So that is the sine function is opposite over the hypotenuse, right? The cosine function is adjacent over the hypotenuse, and then of course tangent is opposite over adjacent. So, then based on that, you can kind of see, okay, we have the hypotenuse, which is given to us. So maybe that you could use either sine or cosine function. Of course, without knowing side B, we are not able to use the tangent function. So maybe not use the tangent. So you can use sine or cosine to find angle A or angle B. Again, look at the angles and then see which side is known to you for you to be able to find A or B. And then Zadok, you actually included, it looks like you probably solved for your angles first and then use that to find side B, right? So you can definitely do that, find the angles first, and then you can find side B. Or remember, you can also use the Pythagorean theorem to find the side, as long as you have two sides of the right triangle known. So I kind of like, Zadok, that you thought about, hey, I'm actually going to find the angles first and then find the side, because, traditionally, we are so used to using the Pythagorean theorem that we just go, okay, we know one of the sides, we know the hypotenuse, we can find the other side. So whichever method comes to you first or is the easiest for you, do that. I'm waiting to see if anybody else wants to share their answer before we move forward, because I want to make sure all of you are comfortable working through, the right triangle trigonometry. So like I said, I kind of like the way Zadok did his math. So I think that's how I will show you. But if you have specific questions, you let me know. So I guess let's start with angle A. So if we wanted to find angle A, you can see for angle A, the opposite side is 7, which means if you're looking at the opposite side, you obviously want to go with the sine function, right? Because the sine is the opposite over the hypotenuse. So looking at angle A, the opposite side is 7. Of course, the hypotenuse is 15. Now, we do not know angle A, right? So this is where the idea of the inverse function comes in. So if we wanted to find angle A, we would then, of course, use the sine inverse function, right? So you would do 7 over 15 for the sine inverse function. I'm pretty sure I had my calculators out here. So let's come down here. We need the sine inverse function. So sine inverse of 7 over 15. And now this is coming out in degrees. Did they tell us if they want us in degrees? Actually, they're not telling us if they want the angles to be in degrees or radians. Hopefully your exam will give you a little bit more information. Okay, sorry. So angle A is coming out to be approximately 27.82 degrees. And again, obviously, if you wanted to change this into radians, then all you have to do is just change the mode on your calculator, right? So if they do ask you for a radian answer, it's not that difficult to come up with that. So 0.86 maybe if we were doing this in radians. And all you really need is that first angle to be known, right? So now that we do have a measurement for angle A, for angle B, now obviously you can use, again, a sine inverse or cosine inverse function if you wanted to, or if you wanted to keep it straightforward for finding angle B, since we know all three angles add up to 180 degrees, the right angle is 90 degrees, so we know angle B um, will be 90 degrees minus angle A, right? So you can use 27.82, or if you were working with radians, then of course you can do pi halves minus that, right? So this will come out to be 90 minus, and I will change this into degrees since we're kind of working with degrees, and I'm just going to use the answer feature to get that. And you can see this guy comes out to be approximately 62.18 degrees, or again, if you wanted to do this in radians, you will have to change this from 90 to pi halves, because otherwise the answer will be incorrect. And yeah, so you can see in radians what your two angle measurements are going to come out to be. So 0.85, I guess, 3 decimal places. All right, so you've got your two angles. You've got your angle A and your angle B. Now, for your side, again, as I mentioned, you can do the Pythagorean theorem, or you can do, honestly, a sine, cosine, tangent function. And looks like, Zadok, you use the tangent function. So let's try and do that. I am going to need a little bit space here, guys. So I'm just going to get rid of this little section here. Alrighty, so let's take a look at how we can find out side B. Now, if you are using the tangent function, remember tangent uses opposite and adjacent sides. Now, at this point, you know both angles A and B, so it honestly does not matter which angle you use. You can use angle A or angle B to figure out the side B. But again, just to kind of keep it simple, let's go with tangent of angle A. So for angle A, again, the opposite side is 7 and the adjacent side is B, right? If you used tangent on angle B, let's say, then for B, angle B, the opposite side would be side B and the adjacent would be 7, right? So it would just depend on which angle you use to simplify this. Of course, we know angle A is 27.82 degrees. And so to get letter B or small b by itself, we can actually multiply both sides by B, and then we would need to divide by tangent of the 27.82 degrees on both sides so that we can get B by itself and then all of our fraction on the other side. So you can see we're basically going to take 7 and divide it by the tangent of 27.82 degrees. So let's see what that guy comes out to be. So 7 divided by tangent of 27.82. And I do want this to be in degree mode because 27.82 is in degree mode. I'm just going to delete my writing for a minute here. So just to show you again, if you're not careful with the mode of the calculator, the answer will come out to be different, because look at the answer in radian mode and look at the answer in degree mode. So just be very, very careful when you are working through that. Now, if you do use the tangent calculation to come up with your side B, you are going to get a decimal answer. As you saw over here, this guy was coming out to be, okay, there we go, 13.27 maybe if we do 2 decimal places. So you will get a decimal answer when you are using the tangent function. However, if you were going to do this by using the Pythagorean theorem, the answer will actually come out to be as a radical. So I guess I will actually show you that, because I'm not sure how the question may be, because the question may not want a decimal answer. So you should then know how to come up with a non-decimal answer. So in that case, guys, we will have to use the Pythagorean theorem. So side 7 squared plus side B squared, those are the two legs of our triangle. will equal the hypotenuse squared, right? 15. So that would, of course, be 49 plus b squared is 225. And then, of course, just getting the b squared by itself. So subtract 49 on both sides. And this is where you get that square root of 176. I think, Nathaniel, you had given me that answer. Yeah, that's where the 176 comes from. So you will end up with b squared equals 176. Now, of course, we again have to do a square root. Typically, again, remember you are ignoring that negative root because we know this is the side of a triangle. So we'll just keep the positive radical. Now, remember again, your textbook leaves the radicals as it is, but you do want to simplify the radicals. So you don't want to leave it at just square root of 176. So this is where you do want to try and figure out what the simplified answer will be. So we want to try and see what is, 76 that can be broken down into. And I think, Logan, you might have shared the simplified answer with me. Yeah, you did have one. Okay, so basically you want to, and this may be a trial and error, but try and see what 176 can be broken down into so that we can get a perfect square. So you can start out with, I just went with 4 because I know 2 is not a perfect square number. So you can see 176 divided by 4 gives you 44. So that means 176 can be broken down into 4 times 44, but then we know 44 can also be broken down into 4 times 11. You can actually see 4 and 4 multiplied together will be 16. So we can actually also write 176 as 16 times 11. And, again, just to show you that the math does actually work, you can do 16 times 11, which gives you 176. Why is that important? Because when you take 176 and rewrite it as 16 times 11, square root of 16 is 4, so 4 can come outside. And of course, 11 being a prime number cannot be broken down anymore. So your b value will come out to be 4 times square root of 11. So Zadok, some questions will ask you for a decimal answer, and some of them will not tell you. If they don't give you specific instructions, then simplify your radical. And then, some of the questions may count your answer wrong. So those will be the questions that I will go back and look at and see if your answer was correct, but just in the incorrect format, then I will try to give you some points for it. Because some questions, they kind of leave ambiguous and they don't tell you like what form they want you to break it down into. But remember, guys, ultimately the answer is still going to be the same. So even if you do square root of 176, let's say if they did ask you for a decimal answer, right? You can see that when we did the tangent function, we got 13.265. And with the square root of 176, it's coming out to be 13.266, right? So the answers are close enough, but depending on which method you use, the rounding can look slightly different from each other. So, but yeah, you should be comfortable using either of these methods to try and solve your right triangle. All right. Did anybody have questions on this guy? Like what process to use, what method to use? Okay. Uh, how about if we were working with a table? So here you can see there's asking us to find a possible formula for the trigonometric functions whose values are in the following tables. So what are some of the things that we are looking at? Let's look at number 5 over here. So you can see we're given the ordered pairs for the x and y coordinates. We've got 0, -2, it goes all the way to 6, 10. So what are you noticing here in this example? And if it helps, you can try and do a rough sketch so you can kind of see what the graph for this might look like. So, okay, Ryder, you said it's a wave with a period of 8. Nathaniel, you're saying power of 3. So I would say that, since we are talking trigonometric functions, you are probably looking more at a sinusoidal graph over here, or maybe even something like, the tangent cotangent functions. So that's why, yeah, kind of doing a graph might help. So you can see our first point is starting out at 0, -2. And again, this is just very approximate graph over here, guys. We've got +1 with 4. We've got 2 with 10. So that's 5, 6, 7, 8, 9, 10. 3 with a 4. 4 with the -2. So you can definitely see that pattern repeating, right? You've got 5, and then at 6, we are back at 10. I probably should have put more spaces horizontally. But basically, you can see we are going from -2 to 4 to 1 on the y value. Then we come back down to 2. We're going down to sorry, not 2. From 10, we went down to 4 to -2, coming up back to 4, back to 10. Really bad graph. I apologize for my bad drawing over here, guys, but you kind of get the idea. Um, yeah, Ryder, you said is it safe to assume that -2 and 10 are the peaks of the waves? Yeah, that's your lowest and highest values, right? Because we can see in the table that there is nothing smaller than -2 given to us and nothing larger than +10. Um, so what would we say here, guys? Sine or cosine? Okay, Logan, you're going with negative cosine. Why negative, Logan?
Well, it's cosine because it crosses the forget the axis at like a maximum. And it's negative because it crosses at the least the lowest point rather than the highest point.
Very good. Yeah, because we started out with 0, -2, right? So since you're starting out at the lowest point for the value, that would be a negative function. And then you said cosine because it's crossing the axis?
Yeah, because it's crossing the x-axis at a value where or when the y value is at a maximum, or in this case, a minimum. So.
Okay. Okay. Alrighty. So can somebody tell me what our amplitude is for this wave, the A value? Yeah, very good. Because remember, your maximum value is 10, your minimum value is -2. So you're basically looking at a distance of 12 units, right? So 12 divided by 2 gives you 6. So that's your amplitude of 6. What's our midline over here, guys? Yeah, midline is at 4 because remember, we keep coming back to that 4 as we go between our highest and lowest values, right? Can anybody tell me what the b value or the period of this function is? So either give me the b value or give me the p value, whatever you're comfortable with. Zadok, are you giving me the B or the P? And Ryder, same question to you. Okay, Logan, you actually gave me a period is 4. So let's take a look at that over here. So you can remember go from either the highest to the highest point or the lowest to the lowest point to figure out what your period is. So if you look at our lowest one is at -2, right? So by the time we start at -2 and come back to -2, you can see your X value changed from 0 to 4, right? So you went 4 units to the right. Or you can again use going from 10 to 10, that's the highest value. So you can see we went from a X value of 2 to 6, which was again 4. So yeah, your period is a unit of 4 units. So remember to calculate the B, you take your original period divided by the new period, which will actually give us, once you simplify that, as pi over 2. So, Zadok, you said you were giving me the B value. So do you see the difference between that answer you gave me, 2 pi over 3 and pi over 2? Do you know how you came up with 2 pi over 3?
Yeah, I was thinking of 6 instead of 4, so I divided and I got pi over 3. I accidentally put in 2.
Okay, okay, got it, got it. And then Ryder, you had an 8 in there. I'm not sure like what numbers you were looking at to give you that number 8. And Nathaniel, you said period equals 4, so that's good. All right, guys, so you've got your A, you've got your B, you've got your midline. So what does our equation look like at this point? I guess I should also ask, is there a horizontal shift? Is our graph moving left or right? Oh, you multiplied it by 2. Okay, that's why you got the 8 there. Okay, got it. Okay, so Logan, you gave me y equals -6 cosine of pi over 2 x, pi over 2x plus 4. Okay, so I have actually not solved this example. So let's see, do we get a graph that looks similar to, what our points are? So we've got -6 cosine of pi over 2 times x, and then plus 4. Okay, so just for our problem right now, I'm going to go ahead and delete the writing. So we should be at 0, -2. That looks good. At +1, we were at 4. Okay, this is not working. 0, -2 falls on our graph, so that looks good. We were at +1 and 4. That looks good. What were our other points? 2, 10. So you should be able to see all those dots show up, right? Wherever we had our ordered pairs, then we had 3, 4. That is again on the graph. We had 4, -2. Back on the graph. what else? 5, 4. And then the last one was 6 and 10. Perfect. You can see that all of these points that you see on the table over here do fall right on our graph. So that works, right? That means our equation was correct. So yeah, great job, guys. This is wonderful. But I do want to show you that this is actually not the only answer. If you look at the answer key from your textbook, you will actually see they did use a positive sign function, but to accommodate that, you are seeing a shift, right? So your graph actually moved 1 unit to the right. So if you take this formula and put it in your Desmos, you should actually come up with the same graph over here. It did not take my pi halves, that's why. Okay, I may have to fix this a little bit, but basically you get the idea, right? Like, there we go. Overlaps, right? So exact same graph. So just keep in mind there is not just one single function. And that's again that beauty and flexibility of working with these functions, right? So you can do a negative cosine function or you can do a positive sine function moved 1 unit to the right and you still get the exact same graph. And the reason I wanted to do this example was because I want you to know that when you look at like these modeling questions, there's not just one way that you are going to come up with your answers. There's going to be, you can use the sine or cosine function, or maybe even secant, cosecant function. So I would say practice with this, guys. You can see there are other examples if you wanted to practice with this. And then I just wanted to very quickly, I know we're kind of short on time over here. I just wanted to show you that the practice has a lot of questions on it, but do not get worried about the number of questions because in the practice, you are seeing like every version of the question that could be shown on the midterm exam. But like, look at questions like 48, 49, 50. They're all very similar, but only one of these will show up on the midterm exam. So I don't want you to like panic and think, oh my God, there are so many questions on the practice. Like same thing, 51, 52, 53 are all very similar, but only one of these versions will show up on your midterm exam. So that's why your practice has like 96 questions, but there are only going to be, if I remember correctly, I think there's only 20 questions or something like that. Well, I did really badly on my midterm practice. But for your practice, for your midterm exam, there are exactly 20 questions. Yeah, so you are only going to have 20 questions on the midterm. So any questions like on the examples we did or anything in general before, we're done for today? Everybody feeling good? Okay, so remember, if you have question about your attendance, stay back and I'll be happy to answer that. And if not, I will see you guys on Tuesday. Good luck, everyone, and have a wonderful weekend. Uh, on the final, I would say anywhere from 20 to 30 questions added. So I try to keep them similar to each other. But yeah, final could be a little bit more, a couple more extra questions. Any other questions? So for the scratch paper, like if you want to use a blank piece of paper, you can. And if you want to send me like a scanned copy or something, you can, but it's not required because again, since you guys are remote setup, I don't make that mandatory. So it's really up to you if you feel like that might help. David, you don't know what your percentage is? I can let you know. So I can get that information to you. Did anybody else have any other questions? Okay.
For
Yeah.
the exam,